Hi, Mr. Causey here. In this question we're given a couple of algebraic fractions and we're asked to divide one by the other. One of the ways you may have been taught to do this, if you're faced with two fractions which you have to divide one by the other, you can replace that division by a multiplication sign, provided you invert the second fraction. And remember the rule for multiplying now: a times d, multiply the top two numbers, multiply the bottom two numbers, and that gives you the final result. So we'll tackle this division in the same way. However, one of the things that we should note when we're dealing with multiplying fractions together, there's a lot of cancelling that can go on, and the cancelling is to do with factors of these numbers. So if a factor on the top of 4, we divide the top and the bottom of the fractions by 4, and basically that 4 disappears. If we find a 2, factor 2 and a factor 2, we can divide top and bottom by that factor. And if there's no more factors in common, we just multiply the top numbers and multiply the bottom numbers. So that would give us 2/5. So factors are worth looking for. And in this case, n squared minus 4 can be factorised. It's a difference of two squares. It's n squared minus 2 squared, and the pattern for factorising something like that is n minus 2 times n plus 2. You can always check that using the FOIL technique of the firsts, multiplying out firsts. N times n is n squared. The outside 2 give you 2n, the inside 2 give you negative 2n, so they cancel. And the last 2, negative 2 times positive 2, gives you the negative 4. So a difference of two squares pattern can always be factorised in a similar manner. A squared minus b squared is a minus b times a plus b. So this n squared minus 4 expression can be factored into n minus 2 times n plus 2. So there's two factors there. Let's change this divide to a times. Let's invert this second fraction. So instead of 3 over n minus 2, we've got n minus 2 over 3. And now, just as I cancelled some of these factors off in this case, we can do the same here. We look at factors on the bottom and top. There's an n minus 2 as a factor. N minus 2 divided by n minus 2 goes 1, and n minus 2 into n minus 2 goes 1. We're dividing top and bottom of this fraction by n minus 2. There are no more factors in common, so I can now multiply top two numbers n times 1, bottom two numbers n plus 2, multiplied by the 3s. 3 lots of n plus 2. And that's the thing simplified as far as it can go. There are no more factors that can be cancelled. So that's one way of doing this problem. Let's now have a look at another way of tackling probably a way that you've not seen before. So let's take n over n squared minus 4, which we know is n minus 2 over n plus 2. That's the first fraction, and we're dividing that by the second fraction. So that's just writing down exactly what we're doing. This first fraction divided by the second fraction. Now, one of the golden rules of simplifying fractions or doing fraction problems is you're able to multiply top and bottom of a fraction by the same number. So for instance, a half, we can double the top number, double the bottom number to get equivalent fractions. Multiply the top number by 3 so long as we multiply the bottom number by the same factor. So let's look at the top and the bottom of this, and let's multiply the top of this big fraction by the factor n minus 2. Now the reason I'm doing that is because this and this will cancel. But I can't do that on the top without multiplying the bottom by the same factor. And then there's an n plus 2 sitting here, which would be nice to get rid of. So let's multiply the top of this big fraction by n plus 2, provided we do the same on the bottom. So all I've done is balance a fraction just like I was doing here, multiplying by 2 top and bottom, or multiplying by 3 top and bottom. Now let's do the cancellings. N minus 2, n minus 2. Cancellings here, n minus 2, n minus 2. Let's look at the result of all that. Well, there's another cancelling I forgot to do, the n plus 2 and the n plus 2. So what's left on the top of the big fraction? Just n. What's left on the bottom? 3 times that n plus 2. So again we get exactly the same result as we had previously. So this is probably a method you've not seen before. It looks a lot more complicated. If you prefer the times and then inverting the second fraction, then happy to do that. So that's Mr. Corsi signing out, and thanks for watching this video.